Math 1314, Section IC1, Spring 2022, Tyler Junior College, Section 5.2, Circles, Video 1, the standard form for the equation of a circle. You may have noticed that I just switched to Section 5.2. My original plan was to do one series of videos for both 5.1 and 5.2, but I went ahead and split them into two smaller series. Does it change anything? Absolutely not. But there is one homework assignment that covers both 5.1 and 5.2. It's a rather short assignment. So that's why these are all in one module together. All right. So if we're going to talk about the equation of a circle, we should probably first start by asking the following somewhat obvious, but not so easy to answer question. What is a circle? Now, everybody knows what a circle is, but try defining one for somebody. Like if somebody did not know what a circle was and you were trying to tell them how to draw it, like over the phone or something, what would you tell them? It's a round shape. Well, I could draw this circle. Okay, it's not closed. Well, here, I got a tool here. Circle. Why is that not a circle? Well, at some point you have to start thinking about distances and parts of a circle. For example, if I were to compare that shape, which is not a circle, you might call it an oval. Its technical mathematical name is an ellipse, but I'm sure most of us would say that, hold on, this is supposed to be drawing a circle. Let me get rid of that. Okay, draw it. This time draw it like a circle. There we go, that's a circle. All right, so what makes the thing on the right a circle but not the thing on the left? They're both round. And if you're saying it has something to do with radius, diameter, or distance, or center, you're right, 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 and right. What makes a circle is that it has two features that define it: a center and a distance from the center to the edge called the radius, which is typically called r. On a circle, the distance from the center to the edge is the same no matter where you go on the circle, assuming that this is actually the center. Whereas in an ellipse, the distance from the center to the edge varies. For example, if you go straight up, you get the smallest possible distance, which in the context of talking about ellipses is often called lowercase r. And if you go all the way across, you get a largest distance, which is capital R, for the biggest radius, if you will. But when you go anywhere else, you get some value in between. So what makes a circle a circle? If you were to tie a string from the center to any point on the circle and then move around the circle, the string would always be the same length. But in an ellipse, if you were to tie let's say it's a rubber band so it can stretch, then it would be at its shortest here, it would be at its longest here, and everywhere in between it would be an intermediate distance. So yeah, what makes a circle, every point on the circle is the same distance from the center, as opposed to an ellipse or any other shape that's not a circle. So that's what makes a circle a circle. Every point on the circle is the same distance, and that distance is called the radius from the center. So that's what makes a circle a circle. Now, why is it important for us to define this? Because we need to be able to we need to find a way to objectively write how you get to be on a circle in terms of equations. Well, let's get right to it. Normally, I would do a specific example and turn it into a generic, but in this case, we're going to jump right into the generic. Let's start, I'm not sure what happened there. Let's start with just some generic circle. Now, a circle has to have a certain center, so we're going to start by drawing a circle and labeling its center something generic. Here's a circle. And there's a lot of ways to generically represent the center, but for whatever reason, I don't know the answer to this, when you generically represent the center of a circle, it is almost always universally, without fail, labeled generically as h comma k. I do not know who decided this is what we'll use. I know why there's not an I, because that's the square root of -1. I know why there's not a J. That letter is reserved in physics and an upper level mathematics. So I know why I and J are skipped, but I don't know why they decided H and K. I would call, if I invented math, I would call it XC and YC. because it's the X coordinate of the center and the Y coordinate of the center. But I wasn't there when this decision was made. All right, so to define a circle, we need to first know where its center is located, and we need to have something to represent its radius. So I'm going to pick any point on the edge, connect it to the center, and we're going to call that distance R. Now be careful. When I say call this distance R, it's a single value measuring how long that is. It's not an X or a Y coordinate. It is simply R for radius. Now, how does one get to be on this circle if your distance from the center is R? So how are we going to write this algebraically? Well, let's generically represent a point on the edge as X comma Y. And again, the H comma K is specifically the center from a generic perspective. We don't know where it is, but it's the center of the circle. The X and the Y on the outside is any point on the circle. We don't know its coordinates, so we call it X comma Y. And how do you get to be on the circle? Well, we've already said this, but the way you get to be on the circle is the distance from H comma K to X comma Y is R. That's how you get to be on a circle, if you are the correct distance from the center. So how can we turn this into an equation? Well, we could if we had a formula for distance. Oh, wait, we do. I'm not going to rewrite the distance formula. It should be in your notes. But we know that the distance formula is the square root of the sum of the squares of the differences of the X coordinates, so second X minus first X, which in this case is X minus H, and the difference in the Y coordinate, second Y minus the first Y would be Y minus K. And that distance is or is equal to the radius. So we technically have our equation. It'd look better if we squared both sides. So imagine squaring both sides. It would cancel the square root and leave everything underneath it. That's what would happen on the left, and on the right, the R would get squared. And ladies and gentlemen, I present to you the standard form for the equation of a circle. If I invented things, I would call it the center radius form because it contains the center and the radius. So let's write this on the next page as our results. Let's bump the font size back up to 36. And here we go. The standard form of the equation, I can never type that word right. The standard form of the equation of a circle with center H comma K and radius R is, and I'm just going to rewrite the last thing that was on the last page, and that was X minus H in parentheses squared plus open parentheses Y minus K close parentheses squared is equal to R squared. All right, so it's not a difficult equation. It stems directly from the distance formula, which stems directly from the Pythagorean theorem. This looks very Pythagorean in nature. A squared plus B squared equals C squared. X minus H squared plus Y minus K squared equals R squared. It's really just the Pythagorean theorem in disguise. So what am I going to want you to do with the equation of the circle? Well, there's a lot of things we can do, but there's two main skills that I want you to be able to demonstrate. Given the center and radius, write the equation of the circle in standard form. For our first example, we're going to look at a circle whose centered at 0, 0, and whose radius is 5. And by the way, this would be really easy to draw. You don't have to draw it to answer this question. But to draw a circle, the first thing you do is locate its radius, which in this case is right at the origin. But then you got to find some points to draw the circle through. And the best way to find those points is to take whatever the radius is and go in 4 directions: right, left, up, and down. If I go to the right 5, put a dot, go up 5, and put a dot, that was only up 4. Go left 5, and put a dot, and go down 5, and put a dot. then I've got 4 dots through which I can draw a circle. Now, I'm not going to use the circle tool here because I know it's not going to be a perfect circle. But when I draw a circle, I actually draw 4 quarter circles because it's easier for me to draw part of the circle better than to try to draw the entire circle. It's not a perfect circle, but I've drawn much worse. So it's not really that hard to draw. But the question wasn't to draw it. The question was to give the equation of it. Well, all we have to do is identify the pieces that are going to go into the formula. The center generically is h comma k, and of course the radius is r. So all we have to do is take our equation of the circle, which is x minus h in parentheses squared plus y minus k in parentheses squared equals r squared. Rewrite that with all the correct values inserted. For the first example, it would be, a second, folks, I'm having formatting issues here. All right, in the first example, the setup would be open parentheses x minus 0 close parentheses squared plus open parentheses y minus 0 close parentheses squared equals 5 squared. And once you set up the equation, you look for things to clean up. For example, don't ever leave a minus 0 unfinished. So 0 is the only number you can always complete the subtraction. X minus 0 is x, and since there's only a single term in the parentheses now, I don't need them anymore, and I can just write x squared. Similarly, I can write y squared. And the other thing to clean up is square your radius. My radius was 5. It's getting squared. 5 squared is 25. The equation of a circle with center 0, 0 and radius 5 is x squared plus y squared equals 25. What do you think the main issues are in the next one, where the center is 3, -4 and the radius is the square root of 11? It has 2 issues of contention that usually gives students trouble. One of them is fairly obvious. The other one's stealthier, but still somewhat obvious. Let's start by setting everything up. X minus something squared plus y minus something squared is equal to something squared. And label the pieces going in. H is 3, K is -4, R is the square root of 11. If we substitute those values in, we get X minus 3 in the first parentheses, but in the second one, we get Y minus -4. Make that minus a little bit better. Y minus -4. And the number we're squaring for the radius is the square root of 11. Sometimes the subtraction problem just sits there like X minus 3, nothing to do there. Sometimes, however, you do minus a negative, like y minus -4, in which case it would become a y plus 4. But what about on the right side? What happens when you square the square root of 11? Well, by now we've seen 2 different situations where squares and square roots run into each other and they cancel. The same thing happens here and you're left with just an 11. When you square a square root, you lose the square root and you get back the number that was under the radical, trying to draw a rectangle. So watch out for double negatives because your formula has a minus in it already. And make sure you remember to square the radius. All right, so that's the first type of question you're going to be expected to do. Here's the center and the radius. Go give me the equation. The second type is the reverse. Here's the equation. Give me the center and the radius. Number 2, given the equation in standard form, determine the center and the radius. For example, determine the center and the radius. Sketch the graph. Our equation is open parentheses x plus 1 squared, open parentheses x plus 1 close parentheses squared plus open parentheses y minus 3 close parentheses squared equals 9. So how do we pull out the center and the radius? Well, recall once again that our equation in general form, in standard form, is open parentheses x minus h close parentheses squared plus open parentheses y minus k close parentheses squared is equal to r squared, but the numbers being subtracted, h and k, that makes up the center. And of course, the number being squared makes up the radius. Well, in the previous version of this problem, we put the numbers in and squared the radius. So when we go backwards, we have to take the numbers out and unsquare the radius. So how do we do that? Carefully. Question. If the center's coordinates are the numbers being subtracted from x and y, what are the coordinates of the center in this example? Now, most people will incorrectly say the following. The center is 1, -3. Congratulations, you found the wrong center. And the reason they say that is because +1 and -3 are the numbers that they see. But the center isn't the numbers that you see. The center is the numbers being subtracted from the X and the Y. For example, let's start with the Y because that one's actually being subtracted. The Y coordinate of the center is the number being subtracted from the Y. And what number is being subtracted from the Y here? The number being subtracted from the Y is 3. That means that the Y coordinate of my center is 3. It's the number being subtracted from the Y. But the X coordinate is the number being subtracted from the X. So what number is being subtracted from the X? Now, if you said 1, wrong, because 1 is the number being added to the X, not subtracted. So what do we do? How can I possibly look at X plus 1 and answer the question, what's being subtracted from the X? Now, I know a lot of you probably know that the X coordinate of the center is -1, but bear with me for a second. If I'm trying to remove the number being subtracted from the X, like up here it says X minus H, I need the number subtracted from the H, but there is no number being subtracted from the X, only a number being added. How do we fix that? The answer is using a move that you rarely ever see in math. Most of the time you see it in the other direction. In fact, you saw it back here. You saw it right here. When you have minus and negative, you're almost always expected to turn it into a plus. But over here, I have a plus and I need to see a minus. So I have to unchange the plus into a minus negative. And again, this is a move that is rarely ever done in math, where you have a perfectly good plus just sitting there minding its own business, and then rewrite it as minus and negative. But it's a legitimate move because if we can do it forward, we should be able to do it backwards. And by writing it as X minus -1, it now allows us to answer the question, what is being subtracted from the X? And what's being subtracted from the X is -1. That's the X coordinate of the center. Now, do you have to think all that? No. If you know that when you pull the center out, you change the signs, that's all you really need to know. Just like when I put the center in, for example, on the second example, or even on the first example, well, it was 0, so forget that. But on the second example, when I put the center in, it looks like it changes signs. That's because I put it in following a minus. And this -4 ended up being a +4. So the net result of putting those coordinates of the center into the equation is they change signs because you put them after a minus. So if they change signs going in, it makes sense that they change signs coming back out. In this case, when I took the center coordinates out in the equation, they were +1 and -3. But when I take them out, I change their signs. And so the center is -1, +3. It's not difficult to do. It's just something to be aware of. Get rid of that there. All right. So to pull the center out, change the signs of the numbers in the parentheses with the X and the Y. Now, what about the radius? Well, it's not 9 and it's not 81. Because remember, this is the radius squared. So we have to unsquare it by square rooting it. Our radius is the square root of 9, which of course is 3. Now, in some of the homework problems, it won't be something as simple as the square root of 3. Like it might be the square root of 10, which would just sit there. I'm sorry, it won't be as simple as the square root of 9, which is 3. It could have been something like the square root of 10 or the square root of 11 like it was here. Or it could even be something like the square root of 40, where you would be expected to break it down into the square root of 4 times the square root of 10, do the square root of 4, and therefore in the equation, it would end up being 2 times the square root of 10. Just keep in mind that the last number in an equation in standard form is the square of the radius. So if the question is what's the radius, you have to square root it. We're also going to sketch this graph, and there are some homework questions where you have to click things to sketch the graph. I'll let you contact me if you need some assistance. Most of it's fairly intuitive, but it's easy to draw a circle if you know its center and if you know its radius. So let's do that. Our center is -1, 3, and our radius is 3. Now, when you're drawing a graph, it helps to think about where you're going to put stuff. Our center is at -1, 3, so I have to go to the left and up. So I need some room in quadrant 2. I wanted that to be black. Okay, let's mark up. Okay, our center's at -1, 3. Wait, is that right? -1, 3. So back 1 and up 3. So our center is right here. Go ahead and write that over here. Center is -1, 3. And our radius was 3. Which means from the center, we need to go 4 directions, moving 3 every time we do up, down, left, and right. If I go up 3, I'm already up 3, so I have to go up 3 more. Put a point here. Where would that point be? Well, the center was at -1 up 3, and it just went up 3 more, so it's at -1, 6. If we went down 3 from the center, it would put us right on the x-axis, and that's the point -1, 0. If we go to the right 3 from the center, taking us to the right 1 puts us back on the y-axis, so we need 2 more spaces, 1, 2, 3. And it looks like that ordered pair is 2, 3. That makes sense. It's up the same amount as the center. So it's up 3, just like the center is up 3. But I added 3 to the x. -1 plus 3 is 2. And we would also want to go to the left 3. So 1, 2, 3, put a dot. It's still up the same amount as the center, so it's still up 3. But if I was at -1 and went 3 more to the left, that would be -4. And we've got our west, north, east, and south points on the circle. And there's our center. And there's our circle, excuse me. So those are the 2 skills I want you to be familiar with using a circle. Given the center and radius, write the equation. So putting the center and the radius into this equation up here. And given the equation, give me the center and the radius. So being able to pull the center and radius out of an equation right there. All right, and of course, being able to sketch a graph. And that's actually the last video in the series for circles. Wait a minute, was that the only video in the series for circles? This was supposed to be 2 videos. Oh well, I did it all in one. It happens.